All right, lecture 11, unit conversions. We have 7 problems to do. I'm going to go until they're done. Hopefully it'll be under 15 minutes. We'll see. So convert 156 milliseconds to megaseconds. So what we'll need to do is find a conversion factor between milliseconds and megaseconds. If you don't know what it is offhand, they're powers of 10 here because it's metric. So you might be able to figure it out, but I never do that because there's a simple, straightforward way. It takes a little bit longer than just the one step of converting from milli to mega, but it keeps you from making any mistakes. Since it's in, we have the metric system here, we'd go to seconds and then from milliseconds to seconds and from seconds to megaseconds, because we know the power of 10, that's the relationship between milliseconds and seconds, and then between seconds and megaseconds. It's very simple. So if we have milliseconds, since this is milliseconds, this has to be milliseconds to cancel. That's what we're trying to do, is get rid of those units in place of new ones, and that's 1 second. And sometimes you'll see people put 1 millisecond, and this will be 10 to the minus 3 seconds. It's up to you whichever way you want to do it. I normally try to avoid any kind of negative scientific notation or exponents that are negative. That's just my choice. And then we have seconds, but that's not what we're after. We want megaseconds, so seconds will be on the bottom here. And 1 megasecond is 10 to the 6th seconds. So the big thing is make sure that the top and the bottom of your conversion factor are equal. 1 second is 1,000 milliseconds. 1 megasecond is 10 to the 6th seconds. And that as you move along, you're canceling. We have milliseconds get canceled, seconds get canceled. We're left with megaseconds. That's what we wanted. So we should be all set. Now, it's going to be 156 divided by 1,000 divided by a million. So this comes up to be 1.56 times 10 to the, should be negative 7. There's 4, let me double check, and then megaseconds. So a couple of things. First, these relationships are exact. So these are exact numbers. So we can look at our measurement here, our earlier measurement, or the initial measurement. That's 3 significant figures. So our result should have 3 significant figures. That's why we put it in scientific notation. Second thing is, once you get done, you should always stop to see, does it make any sense? Well, megaseconds, that's 1,000,000 seconds, so that's a very, very long time. 156 milliseconds is less than a second, so that's very short time. So if we're going to convert a very short time to units that are for a very large time, we should expect a very small number in the end. So that doesn't mean that we're right. You want to double check, but 1.56 times 10 to the minus 7 milliseconds is a very small number, and it should be. If we're going to use megaseconds for whatever reason to denote a very short time, it should be a very small number. So just check the physicality of what you're saying. If this turns out, this came up to be plus 7, then you're saying it's 10 million megaseconds. I mean, that's offhand, I'm not sure. Well, let's see. So 1.567 times, and that would come up to be 495,000 years if this was a plus 7. So just checking the physicality of these problems. I know it took me a little time to talk about that, but it's very important that you always check what you're doing, because it's not good to get something wrong, but when it's so obviously wrong, that's the worst. When you look at it and say, oh geez, that doesn't make any sense at all, and I just skipped right over it. Okay, so convert 25.3 mils to gallons. Again, this is a very small volume. A gallon is a very large amount. It's about 4,000 mils. So we'd expect that our answer would be a very small one when we get done. So it's nice to know where we're headed. We don't have the conversion factor between mils and gallons, but we do have liters to gallons. So if we were to convert using this exact relationship to liters, and then you have to be told, but since it's from metric to English, we saw this in an earlier lecture as well, that is inexact. So this is 3 significant figures, so are these. So if this was 4, we'd still have to give our answer as 3 significant figures. So 25.3 divided by 1,000 times 0.26, and we get 0.00668 gallons. Now, for me, I'm happy with. It's a very small number, so that makes sense. But I'm happy with this. I can read this. That's not a problem. But you might be asked sometimes to change over to scientific notation. All right, and once you get past leading zeros, it gets a little tough for me to. I have to kind of count to see it, and see what the number is. But that's fine for me. For others, you might have to convert it to scientific notation. Okay, so convert 115 millimeters squared to decimeters squared. Okay, so we're going to have to go through meters, but also it's squared. So we have another problem. We take 115 millimeters squared. Well, how many millimeters squared are there in a meter squared? Because we're in units of area, so that's what we're going to have to do. Well, I don't know. I mean, I guess I could figure it out pretty easily in my head because it's powers of 10, but let's say we know that there's 1,000 millimeters in 1 meter. That's something that we know. And if we were to just square this whole thing, remember the top is equal to the bottom, always. So since the top is equal to the bottom and the numerator is equal to the denominator, this is 1. It's a strange form of 1, but this whole thing is equal to 1, so if we square 1, we end up with 1, so it's okay to do it. But if you're now, if we bring this 2 in, we square the units, but we also square the numbers. That's the big thing. Squaring 1 doesn't do anything, but squaring 1,000 changes 1,000 to 1,000,000. So you have to do it. Make sure when you bring that in. Now we have millimeters squared. We have meters squared. Looks good. We go on to the next one. 1 meter is 10 decimeters, and if we square it, we're just squaring 1 again. Bring the 2 in. Boom, boom, boom. Meters cancel. Millimeters squared cancel. And now we have 115 divided by 1,000,000 times 100. Just make sure I got that right. And so this comes up to be 0.0115 decimeters squared. So I'm going to just redo that just to double check. There's a lot going on there. Decimeter is 1/10, so there's 10 decimeters in a meter, and then we square it so it's times 100, and that looks like the right answer. Okay. Convert 16.7 kilometers cubed to nanometers cubed. Okay, so a nanometer cubed is about the size of an atom, and then a kilometers cubed, that's a kilometer on a side. This is an enormous volume, and there's 16.7 of them. So we should expect, if we're going to convert kilometers cubed to nanometers cubed, that our answer should be gigantic. It shouldn't be 10 to the minus 15. It shouldn't even be something like 10 to the 6th. It's going to be ginormous, the correct scientific term. It should be such a large number that it'll be quite impressive when we're done here. Now, we have to change kilometers to cubed to nanometers cubed. We're going to have to go through meters cubed to do that. Or I do, anyway. If you know the relationship between them, and it's powers of 10, so you can figure it out. But I don't like to mess around and make a mistake. So I go through meters, and this is cubed. And then for every meter, there's 10 to the 9th nanometers. And again, you may have been taught that this is 1 nanometer and 10 to the minus 9 meters. Same thing. It gives you the same answer. I just don't like those negative exponents. They throw me off. So we have, so it's just what you learned, what you're comfortable with. Now this is 10 to the 9th cubed, so this becomes 10 to the 27th. Kilometers cubed cancel, meters cubed cancel, and then we have, okay, so we have 16.7 times 1,000 cubed, so that's going to be 10 to the 9th, times 10 to the 27th, so we end up with 1.67 times 10 to the 37 nanometers cubed. So pretty impressive. Just make sure 10 to the 9th, so that's 10 to the 36. Yep, so that makes sense. So big number, that's what we expected. Convert 15.4 meters per second to kilometers per second. Notice we don't touch the seconds here. We're just converting the top of this derived unit, and that's why we want to do this out. We want to do pretty much every type of conversion factor you're going to see in this course. Now, when we know that there's 1,000 meters per kilometer, and but we want to just convert this unit and not touch this one. So there are 1,000 meters. 1,000 meters per kilometer. See, those cancel, and then when we're done, when multiplied through, we'll have kilometers per second. So that's good. 15.4 divided by 1,000. And this comes up to be 0.0154 kilometers per second. Should be a smaller number like that. That does make sense. And so we haven't touched the seconds, and those were just carried through. Double checking, okay. Next one. Convert 14.3 meters per second to meters per hour. Now we're leaving the meters alone and just doing the changing the unit in the denominator. So we have 14.3 meters per second. Here's where it gets a little tricky. Now what I'm going to use is 1 hour. 1 hour is equal to 3,600 seconds. Now you can do 1 hour is equal to 60 minutes, and 1 minute is 60 seconds, but in this case I'd rather not go that route, since this is a relationship you should know, and it's exact. So we're trying to get rid of seconds, but notice seconds is on the bottom. It's in the denominator this time, so we have to have seconds up here, and then it's hours. They'll be in the bottom, so this would be 3,600 seconds, 1 hour. And since I put hour, I wrote out the word I did down here, but HR will do fine. And in some cases, just H will do for the unit of hour. Notice because one is on bottom, one is on top, they cancel, which they should. 14 point, whoops. And we end up with 5.1, after rounding, 5.15 times 10 to the 4th meters per hour. That makes sense. We're 14.3 meters per second. That's pretty fast. That's moving along pretty quickly. And so we should expect that we cover quite a bit of ground in an hour. But let me double check. 14.3 times 36. Good. And then the last one is where we convert both. We convert meters to miles, seconds to hours. So we have to do both. Meters per second. Now, I'm going to use that 1 mile is equal to 1 kilometer is equal to 0.621 miles. And there's lots of ways to go. That's probably the best one here. So meters, and so which unit do you use change first? Either one. I'll start with meters. Do them one at a time. So 1,000 meters is 1 kilometer. 1 kilometer is 0.621 miles. You'd have to be given that one. I just happen to know it offhand. Now we've changed meters to miles. So if we stopped, we have miles per second, but we want miles per hour. And there's 3,600 seconds per hour. Seconds cancel. And now we've done everything. We've done all the conversions. About 1,000 times 0.621 times 3,600. And this comes out to be 173 miles per hour. And I know that 88 feet per second is 60 miles an hour. This is much more than 88 feet per second. So yeah, we should expect that this is a pretty quick speed. But let me double check. So 76 divided by 1,000. And then times 0.61 times. And I should also point out that this is definitely not an exact number. This is an approximation. So we go out to 3 significant figures. This is 3 significant figures, so our answer can not be any more than 3 significant figures.